My name is Gleb. I am a co-founder and CTO of Hashx blockchain security, and today we will talk about account abstraction, but not from the common point of view about how the cool this technology is, but from the risks side. So this is what this talk is about, and a few words about us. Hashx is a blockchain security company. We focus mostly on the smart contracts audit. One error in a gasless in a library for gasless transactions and 1.5 thousand projects have a vulnerability. According to the Dune, to the current moment, more than 3.5 million account abstraction wallets are deployed, and think about what if a vulnerability is found in one of the popular realization. So a few words about account abstraction, what it's all about. It has been talked since 2016, but with a tight timeline. It wasn't included in the first release of Ethereum, and the first realization was only in 2023. It's a cool technology that allows for many possibilities. You can, for example, pay for transaction with tokens. You can make custom verification logic, and this leads to Web 2 experience in Web 3, which can bring us real mass adoption of the cryptocurrencies. So the better name for account abstraction is, I think, smart wallets, because every wallet is in account abstraction is a smart contract with a custom logic. But this implementing this requires consensus level changes on Ethereum, and the development on Ethereum is focused on the scaling solutions. So for now, the native account abstraction is implemented in some L2s like Zeka, Sync, and Starknet. And let's talk about how it was made possible on Ethereum without making changes to the core protocol. There is an off-chain framework where a user or some entity creates a transaction named a user operation in context on ERC 4337. This user operation goes to mempool, and we have executors acting as block builders in Ethereum, which take these user operations from the mempool. They group them into one transaction and pass them to a singleton contract named the entry point. It's actually the main contract of the account abstraction, which calls the user wallets to verify and execute the actual transaction. Also, we have optional paymasters. These are entities that can sponsor transactions for some reimbursement, or maybe specific transactions may be sponsored even by free. And an optional entity is aggregators. These they aggregate signatures. It's a kind of optimizations for gas costs. So the technology is quite complex, and let's talk about its limitations and the pitfalls. First of all, you need to know that the actual call in the smart contract is not the signer. The EOA, or externally owned account with a private key who sends this transaction, is a bundler. And speaking about the code in smart contracts, usage of the text origin is quite restricted, as it's always points to the bundler. This leads us to a limitation for a common check that was popular not long ago to protect from flash loan attacks, to restrict calling the contract from another contract. It's text origin equals to message sender, and it does not work now with account abstractions. We also need to know that according to how the alt mempool works, the consecutive operations in mempool for one account are not possible. So the developers need to group them first into one and send and wait until these operations are mined. And an important thing to know, especially on Ethereum, notorious for its transaction costs, that, for example, sending an Ethereum from account transaction wallet may require more than 5 times more gas than sending it with EOA. And also, speaking about the transaction costs, to create a wallet, you need to deploy a smart contract, which also a very expensive operation on the Ethereum. So the ERC-4337 is a well-designed system, and we think that the most risks lie in realization of its parts in smart contracts, especially in with the using of signatures in the wallets, because replay attacks and are mostly common, and actually it's very difficult to do the signature verification right, as devs need not only to think about the security of this, but also they need to check that the same signature is not used twice. The only entity that is trusted in this standard is the entry point contract, and some wallets may want to have a function to change it. And this may be the source of another vulnerability when the entry point contract in the wallet is changed to some malicious one. And this is the case that was with Unipass wallet, where the funds could be withdrawn from many wallets. Account abstraction allows creation of allows pre-calculation addresses for not created wallets, and actually an attacker can, if it's not done right, can deploy a wallet that he can control before the at the same address before the user, and withdraw all the funds that are already sent to this address. And speaking about the griefing, accounts, this standard has a lot of parties that don't need to trust each other, but they need to check the operations that everyone, every entity does not try to fraud it. For example, speaking about the paymasters, they reimburse users for the paid gas, and this can also be exploited. And speaking about the denial of service attacks, a wallet, there was a case that a wallet didn't handle the nonce right, and actually the funds on this wallets were blocked. So here is a checklist that developers can look at it to successfully start the project using account abstractions successfully. Thank you. I will be glad to answer any questions.